So, hello NDC. I'm so excited to be here to present this little hacking talk that I've created for you. It's entitled How Hacking Works, and well, we already have seen the answer to that statement in films and movies. So let's check in with Hollywood to see how they view hacking, how it works. So this is from a show called NCIS. You may be familiar with it. It's about a government agency in the US, and they are currently being attacked. And of course, an attack is a duel in real time, of course, with a defender and an attacker. So let's see.
No way.
Makes me stumble because the amount of people involved in this kind of production, not one single individual has spoken up and said this is silly. And of course, the one who saves the day, I haven't seen code like that either, because that's not real code. But the one who saves the day is the non-technical person walking randomly into the room and fixes the problems by unplugging the computer, because evidently all important data and systems for this entire government agency runs on that one terminal. Yes, one win for TV. So back a couple of decades ago, there was also this movie called Hackers, and they probably did the research right, because it's named Hackers, so they should probably look into how it works. And of course, all our hackers have these custom keyboards with symbols instead of characters on them. That's how we do things. And of course, so yeah, that's one hacker down, and now they're fighting another virus.
Run antivirus. Give me a systems display.
Run antivirus, and how you do that is by shooting the virus with a laser gun. That's antivirus for you.
Die, dick.
Yeah. And of course, once they send a rabbit into memory, because it replicates,
Rabbit, flu shot, someone
you send a
talk to
flu
me.
shot.
A rabbit replicates till it
that's not a
overloads
thing.
the file, then it spreads like cancer.
Cancer?
And of course, we all know that cybersecurity professionals have custom keyboards with circular buttons with no symbols on them. So one win for Hollywood there. And this is my favorite of all silly hacking demonstrations in TV and movies. This is from the show Scorpion, about a famous hacker. And you should think that they will get things right. And in this episode, they are fighting malware on a plane that enables a hacker to remotely control that airplane while in flight. So of course, the only way to fix this is patching the plane, and you do that by driving down the runway in a Ferrari, chasing the plane in flight with a member of the flight crew climbing down on the landing gear with an Ethernet cable to plug into a laptop. Because evidently, even though the hackers can remotely access the plane, the defenders can't. They need an Ethernet cable. It's probably a twisted pair since it's directly coupling to the computer, I guess. And of course, we all know hackers have Ferraris and runways to drive and catch a jumbo jet. And of course, they managed to do so in the nick of time, right before the pilot has to take the plane back up again. And now we have a successfully patched flight control system, of course. Yeah, that's how we do things. So, this talk can take a couple different turns depending on what kind of audience, and I also see I have an audience, which was my first nightmare on doing this talk. So that's one nightmare averted. So I'm going to do a quick informal poll on my audience. You do so just by showing hands. There's no software or anything involved. I just want to know how many of you are programmers or coders or developers. Oh wow, there's my coders. And how many of you are tech leads, architects? You work in PowerPoint and draw diagrams and have awesome. And those are important jobs. I had that job many times. How many of you are security engineers, pen testers, or actual hackers? We have one of those, a couple of those. Awesome. How many of you are something completely different? You are a Scrum Master or you are in management? Before we go any further, who am I? My name is Espen Sande-Larsen. I worked as a developer, a tech lead architect, and been doing technology and coding and stuff for 25 plus years. I'm married, I'm the father of 3, and I started developing software when I was 6 years old because my big brother, he traded an illicit substance, meaning drugs, for a Commodore 64, meaning he gave drugs away and got the Commodore 64. And I think that is the drug deal of the century because we would spend the next weeks and months and years of our lives trying to figure out how that machine worked, and I was hooked on that thing. Well, computers, not drugs. And it's intense. And I love programming, I love tinkering with stuff. I do all kinds of sorts of stuff in my spare time and in my professional time. I was also a professional musician for many years, which is non-related. And yeah, that's enough about me. I also used to be a hacker once, but I'm not going to talk about that. Maybe over a beer. So what is this thing? So this talk is designed to get all of you into the mindset of an adversary. Think like a hacker. I'm going to show you some tools and some demonstrations on how these things work. And hopefully by the end of this thing, you will have learned how to find exploits and design them and perform them. And I will turn all of you into hackers by the end of this presentation. I hope so, at least. Before we can do that, we need to define what really hacking is, because it's a term that has been kind of changed over time, what it means, because it used to mean something different. It used to be individuals who were technically proficient, and they would tinker with software and hardware, electronics, and they usually tried to figure out ways to make it do things it wasn't intended to do. And they did that by thinking outside the box and trying to think, what do you do with this thing to get it to do what I want it to do? That was many words. Anyways, one example is like the great Steve Wozniak, how he managed to create a color display output for the Apple II, which is a monochrome machine. There's no video chip in that computer. And he did that by manipulating the NTSC signal and triggering an misalignment of the cathode ray cannon inside the CRT screen that was able to produce colors, which is a kind of hacking. But the thing we call hacking today was originally known as phreaking or phone phreaking, and the people were phone freaks. And that is because back then things weren't interconnected like they are today. There was no internet, well, there was, but it wasn't like it is today. So if you wanted to hack a computer, you would actually have to dial that computer up on the phone and perform your exploits. And that term kind of got moved into hacking once we got the internet and everything started to evolve from there. And what we are talking about in the scope of this talk, when we're talking about hacking, is basically exploiting systems through vulnerabilities. And hackers come in many shapes, forms, and sizes. They are different kind of people from different places of the world with different backgrounds. But you always know their motivation by the color of hat they wear. So they are easy to spot in a room. Because this comes from the old Western movies where the bad guys had black hats and the good guys had white hats. So we kept that. So the black hat people, they are the bad hackers. They do bad stuff. The white hat hackers, they do ethical stuff, only for good. And some are gray hats. They do not necessarily do good or do not necessarily do evil. They are kind of in between. Then we have the green hats. Those are the newbies. They don't do stuff. They are just beginning their hacker journey, and they don't know that much yet, but they started. We have the red hat hackers, and they are not Linux fans. They may be, but that's not their primary function. They hunt other hackers and try to take down other black hat hackers. And the final one is the blue hats, which is basically people who are hired to look at unreleased pieces of software to find vulnerabilities before they are released into the wild. For instance, Microsoft has a great history of inviting blue hat hackers to look at unreleased versions of Windows and other Microsoft products. They even have this yearly event that I can't remember the name of, but it's invite only, and it's basically blue hat hacking. So now we know who the hackers are and what hats they wear. We need to know why these hacks happen in the first place. And they usually happen because developers do stupid stuff. Or they don't do stupid stuff, they make mistakes. And there's several reasons why they make these mistakes, because it could be on purpose, it could be on accident, it could also be that they didn't know that this was a mistake, and that's the usual case. Because we don't know every detail usually about the systems we are programming and the code we're using and the libraries we're using. And often the exploits are in those overlooked complex details. And we tend to trust other people's code like it's candy. Because why write code that other people have written? And with the ecosystems today, it's so easy to download the library and link to that library and use that code. And also we tend as developers to get married to our platforms of choice, and that means we get a hammer, we know how to use it. So even though we need a cement mixer to solve our problems, we still use the hammer because it's so familiar to us. And that may not necessarily be the best tool for the job at hand, and that can cause stuff. Who has been hacked before? Okay, only a couple. Who has worked at a company that has been hacked? Okay, more. Yes. I have been hacked, or my company that I worked for has gotten hacked. Once I was the CTO in a startup, and they had this big ambition of hitting it big, and everybody would get rich and everything. And I was given the opportunity to build up their entire technical platform, which was their product. And that platform was to serve online ads with rich media content on online newspapers throughout Europe and the world. This is back in the day, so this was pretty new. It wasn't a thing on the internet yet. So this had to interconnect all these newspapers through this ad platform, and we would show games from our advertisers where you can win prizes. And we had also integrated directly with the POS systems of our advertisers. So you would win a prize that you could scan, and you would receive that at the point of sale at the advertisers. And we will also collect heaps of data that we can analyze and create these nice reports where we could track other purchases and synergies. Before GDPR, this was fine back then. And when you are in a startup, I got to be the CTO, that's awesome. But it was a startup, limited budget, limited number of people. So I was also the tech lead and the principal developer. So also the principal architect. I had to figure out how to do this thing. This was before there was any clouds. So I didn't have AWS or Azure. I had to build my own cloud. So I had to create a distributed real-time system across Europe and the world. And I had to work with all these rich media content apps. And the kicker was that it had to be done in Flash. And who remembers Flash? Yes, some do. For those of you who don't, Flash was this strange plug-in thing to your browser that enabled you to run code. The code was kind of like JavaScript and kind of like TypeScript. It was called ActionScript, and it was a mess. And the problem was that Flash, well, even though it was compiled, it had bunches of vulnerabilities. And we had this one campaign for a large retail chain in Sweden. I can't name names, that's why I'm trying to be vague, because this is all NDA. But and they had this game, and you could win cinnamon buns that you can scan, and you can get your cinnamon bun. Awesome. One morning, I got a call from my CEO who said, Espen, we have a problem, because there's one person in Sweden who managed to pick up 73 cinnamon buns in one day. How is that possible? And I said, it's not, because you can only get one bun per day per person. At least that was how I had thought I had built the system. And I also thought that guy really likes cinnamon buns. So yeah, and this got a big thing. So I had to figure out how it works. So I found a forum at one of the universities in Sweden, And this one guy had figured out a way to download my binary, and he had decompiled it, and had figured out all the backend calls. And he had then created this little app that he called the Cinnabot that would just get you the price every time you ran it. So awesome. And then we had a meeting with the board. Everybody was mad. You can just imagine all the heated debates on whose fault this is and whose head has to roll and who needs to be killed and fired and all that stuff. And of course, every finger points to me because I built the damn thing. So I had to quickly figure out a way to defend myself. So I said, no, this is great. This is awesome news because now we have fixed a major vulnerability in our entire platform. We should thank this individual. So I got the CEO to pick up a case of cinnamon buns and meet the guy, and we got a 2-page spread in one of the largest newspapers in Sweden with this big tabloid picture of this guy with so many cinnamon buns. So yeah, that worked. But how can we defend against these kinds of situations? And how can we build systems that are more resilient? And one way of doing so is actually learning a bit of how these things function, how they work, and how adversaries think and how they approach doing these kinds of exploits. And one great way of doing that is something called Capture the Flag tournaments, or CTFs. How many of you are familiar with CTFs? Okay, awesome. I will let Mr. Elliot Alderson from the great show Mr. Robot, that's the best hacking show ever on TV, and that literally, I mean that because it shows actual hacking. So I'll let him define it.
The CTF Tournament, Capture the Flag. It's like the Hacker Olympics. Teams are exercising their inner anarchy.
It's awesome. You can exercise your inner anarchy, and it's like the Hacker Olympics. So what are CTFs? For those of you who know, you know, but those of you who don't, it's basically a gamified way to build adversarial techniques, and you do that by solving challenges in different categories. And these categories reflect different aspects of cracking and hacking and security in some way. And they are designed in a way that you are not told what to do. You only get a challenge. Please break me. And you have to use all kinds of ingenuity and imagination and research and a lot of effort to figure out how to do so. And that is an intense catalyst for learning and gaining insight because it requires you to think differently. And the cool thing about this is that once you do one of these tournaments, you kind of spark up the conversation in your organization or in your team or whatever about security. It's suddenly on the agenda. And suddenly, people are talking about SQL injections or protocol exploitations and stuff like that. And it's also really fun to be the bad guy for once in a safe environment. Who am I kidding? It's awesome. It's fun. And I mentioned there are some different categories. I'm just going to browse over them because I really want to have enough time for the demo section because that's where the juicy bits are, at least in my mind. So, but basically, there's a couple ones that are based around cryptography or ways to hide secrets, and that's crypto for cryptography, as Scott Helm also said this morning, where you have to break ciphers, basically, also, usually. And there's steganography, or stego, which is where you hide something inside something else. You can hide like a binary inside an image, or the other way around. We have forensics, which we also have heard about today, which is all about doing data analytics on one set of data. It could be network traffic logs, it could be file systems, or other kinds of digital, other kinds of logs where you're searching for clues. And then we get into the things that are really like actual hacking. We have reverse engineering. We are presented with a binary or a program. You have to figure out how that works and find the vulnerabilities and exploit them. And we have one that's usually called vulnerabilities, and that's what we usually know as supply chain attacks, where it's a vulnerability, not your code, but somebody else's code, a third-party dependency. So, and we have the web category. This is usually all of the above, but it's always centered around web technologies, because there are so many web exploits. It's so fun, so cool. I actually have a version of this talk where we only do web. This is not that one. And finally, this is the creme de la creme. That's the pawning category, where you actually have to take over another service. You can gain shell, or you can gain remote code execution, and take over the entire service. All the different categories have different tools. I'm not going to go into all these tools. I'm going to show you a couple today. So if you want this list, you can take a picture now. But I'll also say that if you arrange a CTF tournament, it's always nice to have a list of these tools available for the people, because not everyone are experienced hackers, so they need some help. Okay. Awesome. And we have done a couple of CTFs. Did I mention I work for DNB Bank? I probably didn't. Okay. So I work for DNB Bank. I'm a banker, but I don't look like one because I'm not really a finance guy. I'm a tech guy. I work in a division called New Tech Lab. It's kind of an R&D division. What we do is we experiment with new technologies, and we figure out new products and services that could be the future, given if things happen. And we also are sent around to do things like this, present at conferences and stuff. And we have a couple of these CTF tournaments that we have arranged called Hack the Bank. And we have used that at universities, at student events. It's a great way to find interns. And we also have used it internally in the bank to get awareness. One of my favorite DNB emails came from a lawyer in legal who sent me an apology email because he was performing a SQL injection attack on my server and had accidentally deleted the entire database. And when we have lawyers performing SQL injection attacks in our group, that's a good day for me. That's awesome. We have done this at NDC, the normal NDC, at our stand. Some of you may have partaken in that before. So that's cool. And we also did a Christmas calendar this Christmas where we had one hack a day. And we do it at talks, and I also hold workshops where we work through more in depth than we are doing now. And quickly, the hacking process is usually something like this. You do a recon and you research and you figure out what's going on, what the pieces of the puzzle are. Then you start testing and probing and figuring out if you can exploit something. Once you can exploit it, you build a POC, a proof of concept, to make it work. And once you have that, you do your exploit. One thing many people forget about in CTFs, real hackers do not forget about this last step, because that's how you avoid detection. But in CTFs, people don't clean up all the time. But it's nice to do so, because sometimes you leave a reverse shell open and nobody else can get into the server because it's single-threaded, for instance. So yeah, but that's the basic thing. So enough talking and more hacking. So I'm going to do some of these CTF challenges now live. No pressure. So let's see if everything is working. I did sacrifice something to the demo gods earlier. So hopefully everything is with me. So let's see. First off, can you see my terminal? Awesome! Can you read my terminal? Great. Okay. There is a parallel talk going on to this one called return-oriented programming, which is actually one of the ways to exploit binary software. So I'm going to start with that. Let's start easy by exploiting a binary. Before we start, how many of you work in managed languages, meaning that you have like a runtime, like .NET, Java, Node, Python? Awesome. How many of you work in native languages, meaning you compile to machine code, running on an actual machine? Awesome. To those of you who work in managed systems, this may be news to you, but there's something underneath the virtual machine, and that is the actual machine. And that's what we're going to look at right now. What things are going on. So let's start. I have a file, it's called ROPME. It's right here, it's a binary. So that's return-oriented program me. So it's a 32-bit ELF executable. It's dynamically linked and it's not stripped. That's good because that will make this demo a little bit easier to understand. So we have another tool we can do to check if there are any compiler fortifications on this thing, to make it more resilient for attacks. So let's do checksec. So we can see that we have railroad partially on, but there's no stack canaries. That means that it doesn't check if the stack has been tampered with, and that means that we can do something that's so cool that's called stack smashing. That sounds bad, but it's really cool. We do have the no executable flag set, meaning that we can't inject executable code on the stack, unfortunately, so no shells. But we don't have the PI enabled, that's positioned independent execution. And that means that if you have the address space layout randomization set on your system in Linux, it will jumble around your functions in memory every time you run your program. So the addresses of your functions are not consistent across different executions. It's not cake. But, okay, so let's just run this thing and see what's going on. So do rot me. It says, yo, enter your name. My name is Espen. Thank you for running this binary. Well, that was uneventful. So let's check out how things are working under the hood. One tool we can use is the GNU debugger. It's an oldie but a goldie. I love this tool. We have had many nice moments together. So let's start by opening this in GDB. And yes, you can attach debuggers to code you haven't written. Is this not visible? I can see somebody reaching. Is that better? Okay. So let's start by checking out if we can find any function names. It's not strips, so we should be able to see something. So we can see all the native library functions that we have linked to up here, and we can see we have 3 custom functions, one called win, one called vulnerable, and one called main. Probably win has something to do with this thing. The awesome thing about the GNU debugger is we can disassemble the code. So let's disassemble main and see what's going on. This gives us the assembly code, and breathe, it's fine. It's not that difficult to understand assembly, it's just a little bit hurdle. And you don't need to really understand this thing on a deep fundamental level to know what's going on and figure out how to exploit it. The important bits are, you see we have these function calls. So we have, for instance, this is puts. It pushes a buffer address on the stack, and it calls puts. This is probably the thing that prints out the yo enter your name at the start. Then it does the same thing again, it pointed to a buffer, and then it calls scanf, probably when it asks me to enter my name. And then it pushes that buffer on the stack and calls the vulnerable function. And then it exits. So that's not that much going on. It didn't call win, by the way, so that's something to note. So let's, just before we move on, let's set a little breakpoint at where we call this vulnerable function. So that's this memory address, so it's 92F3. And let's disassemble the vulnerable function. And you can see it's not that much going on in this one either. So again, it creates a pointer to a buffer, and then it calls string copy, probably copying the argument into that buffer. And then it does a call to printf, printing out that buffer. And then it returns. It doesn't call win either. So with ROPing, we need to use what are called ROP gadgets and build ROP chains. And essentially that is instructions that we can manipulate because we have access to some parts of the memory, and you can chain those together to do cool stuff. And we are going to use this return instruction as our ROP gadget in this example. So I'm going to set a breakpoint at that. That is 080492 So, okay, we have a breakpoint there. Let's just run the thing and see what happens. Yo, enter my name. My name is Espen. We can now see my name is on the stack, and the instruction pointer is at the call to vulnerable. You see the green text. If I step one instruction in, we can see we are now inside the vulnerable function. And if I do a continue, I will stop at my breakpoint, that is return. Note that the return address is now on the top of the stack, and that is back in main. So that's actually what the return does. It just puts that on the stack, and it increments the pointer, or the instruction pointer. So if I do one more, my instruction pointer, I can also see that here. It's now at this position, and I'm back in main. So that's what happened. So how can we exploit this? Well, you may have seen it, and you may have not, but we do not do any buffer checking anywhere to see that we are just reading an amount of data. So we can stack smash by overflowing that buffer. So let me just generate some code, or generate an input for this input. the name. So let's see. Let me use. I'm going to use Perl. Sue me. It's fine. So I'm going to do 100 A's. I'm going to concatenate that by 4 B's. I also need to actually give it a command. So I need to do print. So that, if I run that now, I can now see on the stack it's A repeated 100 times and 4 B's. It's actually a string, but that's just GDB kindly makes it more readable. If I do continue and I go into my return instruction here in the vulnerable function, I can see that nothing really happened. I still have the return address and this thing on the stack. So that wasn't sufficiently big enough to trash that buffer. So I can continue to exit. But now I have a proof of concept, something I can actually test. So if I do this, add 10 more characters. There are ways to calculate this thing, but I'm just going to show you this fast to show you what's going on. So if I do that now, it's 110 times. And if I do continue, we can see something has happened. Because on the top of the stack now, it's no longer returning back to main. It's 802 B's. 42 is the hex code for B. And if I do continue, I will get the segmentation error because the program, the address was invalid. Awesome. But I only managed to overwrite 2 bytes, so I need to add an additional 2 bytes to get a full address. So if I do that, it means I can add 2 characters to that string, run it, continue, and now you can see the return address is 4 B's. And how can I now exploit this? Well, if I do print the address for the win function, I get that there. So I can now modify my attack string by doing this. So I can enter that address instead of those B's. And it's little endian, so I need to do it in reverse. So I just enter the hex escaped characters with D691. 04, 08. And what happens now? This is kind of neat. You can see on the stack, we have now these strange characters. That's those hex values because it's not text anymore. And if I continue, you can now see that the stack pointer is pointing to win. It's also, you can see here on top of the stack. So if I continue now, I enter the win function, and it prints out you win. So I managed to manipulate the control flow of this program by smashing the stack. So that's one way of doing this. I'm going to show you another one. This is another binary exploit, and this is actually from one of the CTFs we had. It's called Jedi Mind Trick. I have the binary locally here. Mind Trick, and it's a 64-bit executable this time. And if I do check sec, we can see we have multiple fortifications in place. So this we can't stack smash. This we can't do anything with, really, actually. And to make it even more difficult, we have it running remotely at this address. So if I just connect to that remote service, I can use netcat. Please enter my name. I say Espen, and then it says, "Hello Espen, but I wanted to go to Tochi Station and pick up some environment converters." And that's not a real flag. That is a decoy flag. So we have to figure out what's going on. So we have to reverse engineer this binary that I have locally. And I'm going to show you another tool. We did GDB. That's awesome. But there's also this great gift from the people at the NSA. Yeah, the NSA has actually given a tool away. It's called Gitra. It's their internal reverse engineering tool. It's awesome. It's so cool. I love this tool. So this thing does heaps of cool stuff. You can use it to create patches or cracks for binaries. You can use it to do so much. I can talk about Gitra for hours. Anyway, I've loaded up my binary in Gitra, enter the dragon. And the cool thing about Gitra is not only can you disassemble code or look up symbols and look up strings and stuff like that, the coolest part of Gitra is that it actually decompiles your binary code. meaning you get code, not assembly instructions. You do get assembly instructions as well, but the fun thing is that it generates this. It looks like C, it's pseudocode, but it's as close to C as it can be. It essentially just looks at the assembly instructions and guesses what kind of C program would produce this. It does it a bit more intelligent than that, but that's essentially what it does. So here we actually see the code of main. You can see we have an array of with different flags. We get a random integer value, and it prints enter your name. Use f. Oops, that's not what I wanted. It uses fget to put your name into a buffer, and it does a printf, and then it prints f the name, and then it puts out the random value from this array. And here you can see the stack canary that checks if the stack has been tampered with, and it will trigger the stack check fail if that has happened. So, anybody see anything wrong here? Yeah, I've seen code like this go out through code reviews in production, but there's one really, really big thing here that's really dangerous, and that is this line 26, printf name. And you may ask, why is that dangerous? Well, printf is basically you print a formatted string, and if all languages have a way of doing this, and what it works by giving it a format specifier, and then you provide an argument, and then it takes that format specifier as a macro and replaces that with that argument. And here I'm calling printf with no arguments other than just the string or the buffer I want to print out. And that is bad because there is no thing as an argument. There's only what we call calling conventions, and machines actually, it's just that calling conventions is, they are linked to the platform you're writing code on, and it basically just tells the program in what arrangement on the stack your arguments are and how you pop them off and how you use them. And that it's a convention because that's what you can expect to happen on your platform. And in this case, printf expects that if it sees a format specifier in that buffer, it will pop a thing off the stack and try to replace that value. And since we don't give that anything, we get the next thing on the stack, which can be anything. So if I run this thing, I can give it a format specifier. If I do %s for string, I will get a hello there. So that something bad happened. Let me just run it locally to see if I can trigger an error. So if I do string, yeah, I get a segmentation fault. So what if I do another one, or if I do I for number? I can see I get 32. So that means that the next thing on the stack is 32. I can also get a hex value. And okay, so that's the next thing off the stack. But how can I use this to do something bad? Well, the format specifier doesn't necessarily have to be the next thing off the stack. It can also be, let's say I want the number 4 thing off the stack as a string. So now it will pop 4 things off the stack and do that. And then I get one of these decoy flags. Strike me down with the power of strings, and I'm about to. So this means that I now have sufficient knowledge to figure out how to kill the server or figure out how to solve this challenge. So I have written an exploit in Python using pawn tools, which is also an awesome library. It's basically super simple. I loop from 0 to 200. I call that remote service. I send a format specifier for a string at the current I, and then I just get back what I receive. And I keep doing that over and over again until I get to 200. So if I run that, so let's do that, Python 3, Jedi exploit. It will call that remote server, and it will just pop up off the stack and leak that back to me. So here is the stack, and eventually I will run out of the program space. Here is the first variable for that first argument to the function, and now we are into the environment variables, which is always nice to leak out from somewhere. And here is the secret flag. That is the secret that we are after in this task. So I managed to leak out basically the entire memory of this machine just by using a format specifier, which is pretty cool. So, how much time do I left? I'm supposed to be finished now. Oh, awesome.
No, I don't know.
Okay. Let me just show you one more quick thing. Let's see. We also have a web challenge. Let's do a web one. That's funny. Let's do Chrome and do hack the bank. So this is one of the CTFs that we have had before internally in DNB. So if I log in, I can find. I'll just do one more quick demo, and then I will just wrap up quickly. 20 minutes. Oh! Now then there will be many demos then. Okay, awesome. Great. So, okay, so this was, I've also opened this CTF for the conference, so you may join and hack and do all sorts of stuff, and you did get a couple of ones for free in this talk. And I also have some nice prizes. I will keep it open until Friday at 6. So you can win some cool Rubik's Cubes from doing this thing. So let's go into the pawn. We have the receipt uploader challenge. So this is a web challenge. It's this awesome web interface evidently enables me to upload a receipt. Usually when we do web challenges, I'd go deep into the code to figure out what's going on there. And we can see that it's a form that targets the upload PHP file. So this is probably PHP, yay, which is always fun. So let's see what we can do. Let's choose a file. I have an image of a cat called hackcat, because it's probably an image since you upload a receipt. And yes, it says it's a genuine image JPEG of my awesome hacker cat. And I can also click that cat. I get the link to the file I uploaded. Awesome. Great. So how can we do anything with this thing? Well, it's PHP, and I love PHP because you can do so much fun things to PHP. Let's just think about what happens here. So I can upload a file to a server, and I can then I get a link to that specific file I uploaded. I can. Does that mean I can upload PHP files? That'd be cool. So I have a little exploit here for PHP. It's basically pretty simple. Echo out the PHP info. See if that works. Let's see if that works. So let's find that. Exploit PHP. Upload. No, that didn't work. That'd be so cool. Of course, they have figured out a way to check that this is an actual image. Well, images are cool. Images have binary data, but they have one thing that maybe this developer hasn't thought about. They also have metadata. And metadata is usually pure plain text. So I'm going to use a tool called exiftool on my hackcat to just see if there is any metadata there. Of course there is. All JPEGs and all PNGs have this metadata. It's nice things, just showing if it's taken with a camera and all that stuff. But we can write our own metadata. I'm using exiftool. And that is a tool that where you can read metadata, but you can also add metadata. So if I add a comment, and if I make that comment be, could it be PHP code? Let's see. Let's just do PHP info to see if that works. So, and I do that on the hackcat. So if I do the exiftool again on the hackcat, I can now see that in the middle, I have a comment that says PHP info. Let's upload that and see what happens. Okay, upload the hackcat. Well, it's still an image. What happens if I click it? Nothing. No. What's wrong? Well, the PHP runtime is only targeted if you have something that's actually named PHP in the file name, at least by default. You can change that, of course. So what happens if I just move my hackcat into hackcat and call it PHP? What happens then? So now let's do hackcat, but let's do the one that's a PHP source file. It's not a PHP source file, it's an image still. Will it accept that file? Yes, and it still thinks it's an image. That's awesome. And what do you think happens when I hit this image now? Well, PHP does what it does best. It screws up everything for you. So PHP just goes through the file and says, Bubba, I don't know this, I don't know this. Oh, PHP, I know this. Boo, there we go. So yeah. And I'm not going to show the rest of this exploit because this is one of the CTF challenges. I've just given you the breadcrumbs to get started. So you have to go do the rest yourself. But that's one. Do we have time for one more? Yeah, we do. Okay, let's see. What do I have? What do I have? Let's do the calculate one. Any JavaScript people or TypeScript people? Yeah, awesome. We love you guys. Let's do another one. This is from the Christmas calendar. This is also open, so I have 2 CTFs running, so you can do which one you want or both. So this has a challenge under this light bulb. It's called the Grinch calculator, and this is one of those supply chain attacks that can happen. So what do we have? We have this awesome interface of a scientific calculator, and it actually does calculations. Wow, imagine that, awesome. So how does this thing work? Well, we can check the source files to see if anything is happening. It seems to be built using Bootstrap, and there's some code. It does execute, and it sends this to a backend endpoint using fetch, basically, with an expression tag. Okay. You can now take this off and do it, but I think it's fun to do it in the calculator, so let's just keep on doing that. I'm going to bring up DevTools and see what happens. So I'm going to just try to overflow this thing to see if I can smash and trigger an error, because error messages are usually leaky. I have to give it a lot of data. Oh man, how much data you are getting now. Come on, come on. Oh, okay, is that enough? No, it's not enough. More data. Come on, come on. Oh, yeah. Okay, let's see. Okay, what happened? 413. Oh, yes. That's awesome. It said payload too large error. Request entity too large at readstream app node modules raw something index.js. Awesome. Now I know this is Node.js. Great. Let's figure out something else. What do I get if I do like E times 2? Do I get something? Okay. What is returned? I get result object and the value. Okay. Can I do like variables? Can I do like b equals 2? What happens then? Let's see. Oh, I got the different results. Something called a result set. And it's using math.js. That's a library. It sounds like one. So that means that this isn't built using the normal math thing. It's using a library. And if I Google math.js exploit, there are several ones actually, but this one caught my attention. And this is basically a guy who figured out how to do RC with math.js because what's known in JavaScript as namespace pollution, where you can actually inject code in place of other code. Because in JavaScript, functions are first-class members, and you can send functions to anything and have them execute and all that glorious stuff. He did this by figuring out how to overwrite the constructor for the cos object, and he didn't find a way to use require to be able to trigger a child process. So he stole the code for child process JS and included that in his exploit because everything is open source, right? So we can just steal the code. We are hackers. We steal. We do whatever we can. And then he was able to trigger a remote code execution. I actually figured out to do it more simply because even though he couldn't find a reference to process, I could. Because, let me just do calcsplit, because in JavaScript, people love to throw references to objects all over the place. They do it like it's confetti. It's sprayed all over. And that means, it also means TypeScript. So I was able to find a pointer to require by using process main module require, and then enable me to load up into the namespace, the child process, and do spawn sync. So if I copy this, let me just not get the ANSI code, so let me just do normal cat instead of bat cat. So then I code this. So this is basically telling that the server or node load up child process, execute spawn sync with ls and dot as the argument. So list directory. What happens? Well, I get back an object, and I can see, let me prettify this for you. I get an object, and it has a property called output. That's an array, and the second element of that array is a buffer. That's probably something we need to check out. So let's do that. So I want output. I want the second element of that array, and that's a buffer. So that means I can call toString on that. So let's see what we get now. Ooh, coding live, awesome. Well, that lists the directory, not locally on my machine, but on the server. So this means that we can do lots of nasty stuff. I can trigger a remote shell, but I happen to know how to solve this, and I only need to do a cat on the index.js. And again, I need the output and the second element of the array, and I can write toString. And by the glorious dark arts that is JavaScript hacking, I get back an object that has entries, and inside that I can see never trust libraries. They are evil inside that code because they are evil. So yeah. Okay, I don't think that's all the demos we have time for. So let me see if we can get this back. Show present. I can't do that. Okay, let's do end slideshow and start from current slide. Awesome. So now we just saw some hacking live. I can do this for hours. I actually have a workshop version of this talk where we do this for 5 hours. It's awesome. It's fun. Anyways, why do we use CTFs? Because the cool thing is that you can do this in a safe environment, and it spreads awareness across your organization, across your group, across your team, and you actually build skills you didn't think you needed or didn't think you would ever actually possess, because many developers don't think of themselves as hackers, and they think that is a difficult thing to do. But it's really just a different mindset, a different thing of approaching a problem. And it's really fun and it's engaging, and we've seen that on NDC at our stand, the big crowds we get when we are doing the live demos. And we had once, the first time, we actually had people taking over the Google stand because they had these Chromebooks and they hadn't brought their laptops, so you could sit on these demo Chromebooks and do all the hacking. That was fun. It's also a great team building exercise, and it builds relationships, and it actually, in the synergies, we actually get better products and more secure services and software. And if you don't know how to get started, there are some great ways that you don't have to build yourself. I just built this myself because I like building stuff. But there are like platforms like Hack the Box or Pico CTF, which are things online where you can just sign up, pay a little money, and you get heaps of challenges to try out. There's also this thing called the Juice Shop, which is this turnkey version of a CTF that you can just download and run. And there's a bunch of stuff on GitHub. I have stuff on GitHub. There are many people that have stuff on GitHub. Both write-ups, which are nice to just get learning, because when you're starting, it's not always evident what you have to do. Only note that if you are hosting a CTF and you're using somebody else's challenges from GitHub or wherever, give them at least credit or ask permission, because it's usually frowned upon to copy things in this community. I learned that the hard way. So yeah, that is customary. And these are the CTFs for you. They are live now, online. You can hack them, and I have these cool Rubik's Cubes. One of them is connected for the winner of the Christmas challenge that you can use in your app on your phone and stuff. And the other one is a regular one for the winner of the V3 one. And I also have a couple of 2x2 Rubik's Cubes for the runners-up. So go out and hack my bank. That's awesome. And that's all I have for now. So thank you. Thank you for joining me in this talk. This is my GitHub and my LinkedIn if you're interested. If you want to follow me, this is what I look like from behind. This is awesome. Thank you.